What if we told you that 20 remarkable space missions might hold the key to rewriting humanity's future? Picture this, unlocking secrets buried deep within alien worlds, sending messages into the vast unknown in search of life beyond Earth, and daring to touch the edges of our solar system and beyond. These missions are not just about rockets and robots, they are about uncovering mysteries that could redefine our place in the cosmos. From exploring distant planets and moons to capturing the awe-inspiring birth of stars, these bold endeavors invite us to venture into the enigmatic depths of outer space. But it is not without danger, not without questions that challenge everything we think we know about the universe. What hidden truths about life, creation, and survival could they reveal? And how could these discoveries ripple back to us here on Earth, forever altering our understanding of existence? Stay with us as we journey through 20 groundbreaking missions that are already reshaping the boundaries of human knowledge and just might change everything. Now turning to the first groundbreaking mission on our list, Apollo 11. This momentous event marked the first time humans set foot on the moon, a milestone that forever changed the trajectory of space exploration. When Neil Armstrong took that historic step in 1969, declaring it one small step for a man, one giant leap for mankind, it was more than just a technological achievement, it was the opening of a new frontier. Beyond the iconic imagery of astronauts walking on the lunar surface, the mission uncovered profound scientific questions about our closest celestial neighbor. For instance, there were peculiar findings within the lunar soil, such as the glassy particles formed from ancient impacts, hinting at the moon's tumultuous history. Could these anomalies provide insight into the early days of our solar system? And what about the moon's composition itself, rich in elements like helium-3, a potential fuel source for future energy needs? This raises a tantalizing question. Could the moon one day serve as a hub for space resource utilization? Apollo 11 not only symbolized human ingenuity, but also opened the door to exploring the deeper mysteries of the moon, leaving us to wonder what secrets still lie hidden beneath its dusty surface. As the next layer of Apollo 11 legacy unfolds, we delve deeper into the moon's intriguing mysteries. One of the most compelling questions centers around its origin. While the widely accepted giant impact hypothesis suggests that a Mars-sized object collided with Earth billions of years ago, forming the moon from the resulting debris, Apollo's lunar samples revealed chemical compositions that challenge this theory. Could there be an even more complex and enigmatic story behind the moon's creation? Moreover, during Apollo missions, astronauts deployed seismometers that detected unexpected seismic activity, or moonquakes, some of which seemed to originate from deep within the lunar crust. What could be causing these tremors on a body that lacks tectonic plate movement like Earth? These findings hint at hidden layers of geological activity, suggesting the moon may be far from the silent, inactive world we once thought it to be. Imagine what further exploration could uncover, perhaps hidden caverns, underground water reservoirs, or even remnants of an ancient volcanic past. If such discoveries are waiting beneath the moon's surface, they could revolutionize our understanding of how celestial bodies evolve and interact. The moon is not merely a static rock orbiting Earth. It is a dynamic entity full of secrets that hold the potential to reshape our knowledge of the entire solar system. With each mission, we uncover more questions, making the moon a scientific treasure trove still waiting to be unlocked. Now turning to the remarkable journey of Voyager 1, this mission represents humanity's first steps into the vast unknown beyond our solar system. Launched in the late 1970s, Voyager 1 has traveled farther than any human-made object in history, venturing into the enigmatic realm of interstellar space. What lies beyond the protective bubble of our sun's influence, known as the heliosphere, remains one of the greatest cosmic mysteries. Voyager 1 data has already revealed unexpected phenomena in the interstellar medium, the space between stars, such as peculiar shifts in magnetic fields and particle densities. These findings challenge our understanding of how our solar system interacts with the galaxy at large. Yet, it is not just the scientific instruments on board Voyager 1 that make it extraordinary, it is also the golden record it carries. This carefully curated message includes sounds, music, and images from Earth, along with greetings in many languages, intended as a cosmic postcard should intelligent extraterrestrial civilizations ever encounter the probe. The thought of Voyager 1 drifting silently through the galaxy, carrying humanity's message of curiosity and connection, stirs profound questions. What if it is someday discovered by alien life? Could it serve as the first bridge between civilizations, forever altering humanity's understanding of its place in the universe? Each piece of data Voyager 1 sends back, and every moment it journeys deeper into interstellar space, brings us closer to answers, or perhaps even more questions about the boundless depths of the cosmos. This tiny spacecraft voyaging through the infinite reminds us of the immensity of what we have yet to learn. As we reflect on its achievements, it sets the stage for even more ambitious missions to follow in its wake. Moving forward, Voyager 2 takes center stage as a trailblazer in our exploration of the outer planets. Unlike its twin, Voyager 1, which ventured into interstellar space sooner, Voyager 2 embarked on a unique trajectory that allowed it to visit all four of the gas giants Jupiter, Saturn, Uranus, and Neptune, offering humanity its only up-close look at the latter two. As it passed Uranus in the mid-1980s, Voyager 2 uncovered astonishing details that continue to baffle scientists to this day. Uranus, with its pale blue-green hue, presented an enigma with its extreme axial tilt rotating almost completely on its side. This unusual orientation likely stems from a colossal collision with an Earth-sized object billions of years ago, a theory that raises further questions about the chaotic early days of our solar system. The planet's magnetic field also delivered surprises, as it is significantly tilted compared to its rotational axis, creating a wildly asymmetric structure unlike anything observed on other planets. And then came Neptune, the solar system's most distant planet, where Voyager 2 unveiled a world of dynamic weather and breathtaking mysteries. Neptune's deep blue atmosphere, marked by winds exceeding 1,000 miles per hour, hosts massive storms, including the Great Dark Spot, a tempest comparable in size to Earth itself. Yet this storm, observed during Voyager 2 flyby, vanished just a few years later, leaving questions about the planet's atmospheric processes and the forces driving these extreme weather patterns. Perhaps most captivating, Voyager 2's journey past Neptune also revealed its moon, Triton, a frozen world that orbits in the opposite direction of Neptune's rotation, an oddity suggesting that Triton might be a captured object from the distant Kuiper Belt. With geysers of nitrogen erupting from its surface, Triton hinted at the possibility of subterranean activity, drawing parallels to worlds like Europa and Enceladus that could potentially harbor life. The discoveries made by Voyager 2 reshaped our understanding of the outer planets and their moons, transforming these once distant dots of light into rich, dynamic worlds. Each revelation serves as a reminder of how much there is left to uncover, and how missions like Voyager 2 pave the way for future explorations to probe even deeper into the secrets of our cosmic neighborhood. With the next phase of the journey in sight, we turn our attention to the Hubble Space Telescope, a mission that has revolutionized our understanding of the universe like no other. Launched in the spring of 1990, Hubble was designed to peer deeper into the cosmos than any telescope before it, and it has exceeded expectations in every possible way. By orbiting above Earth's atmosphere, it eliminated the distortions caused by air currents, providing crystal-clear images of distant galaxies, nebulae, and other celestial phenomena. One of Hubble's most groundbreaking achievements lies in its contributions to dark energy research, a mysterious force driving the accelerated expansion of the universe. Through observations of distant supernova, Hubble provided key evidence that the universe is not just expanding but doing so at an ever-increasing rate, a discovery that earned scientists a Nobel Prize and left us grappling with the question of what dark energy truly is. Beyond this, Hubble has played a crucial role in the search for exoplanets, planets orbiting stars beyond our solar system. By studying the light passing through the atmospheres of these distant worlds, Hubble has identified elements like water vapor, hinting at the possibility of conditions suitable for life. Its ability to unlock secrets of faraway star systems has opened the door to one of humanity's most profound questions: are we alone in the universe? Hubble also gave us a glimpse into our own beginnings, capturing images of galaxies formed billions of years ago, just a few 100 million years after the Big Bang. These snapshots of the early universe have helped scientists piece together how stars and galaxies evolved over cosmic time, painting a vivid picture of how everything we see today came to be. Even as it nears the end of its operational life, the Hubble Space Telescope continues to be a cornerstone of modern astronomy, inspiring awe and igniting curiosity around the globe. Its legacy sets the stage for future telescopes like the James Webb Space Telescope to delve even deeper into the mysteries of existence. Now turning to Mars, our closest planetary neighbor, we encounter a series of robotic explorers that have transformed our understanding of the Red Planet. The Mars rovers Spirit, Opportunity, Curiosity, and Perseverance have each played a pivotal role in unraveling the secrets of this mysterious world. Spirit and Opportunity, twin rovers launched in the early 2000s, were designed for missions expected to last just a few months. Yet, they far exceeded those expectations, with Opportunity exploring for nearly 15 years. During their time on Mars, they uncovered compelling evidence of ancient water flows, such as mineral deposits that could only form in the presence of liquid water. These findings hinted at a Mars that was once warmer, wetter, and possibly capable of supporting life. Curiosity took this investigation a step further, landing in the enormous Gale crater in 2012. Equipped with advanced scientific instruments, it analyzed Martian soil and rock for organic compounds, the building blocks of life. Curiosity's discovery of complex organic molecules and seasonal fluctuations of methane in Mars' atmosphere raised tantalizing questions about whether life might have existed or even still exist on the planet. And then came Perseverance, which landed in Jezero crater in 2021, a site believed to have once hosted a lake. With its groundbreaking technology, Perseverance not only studies Mars' geology and climate history, but also collects rock samples, preparing them for possible return to Earth. These samples could hold the key to answering one of humanity's most profound questions: is life unique to Earth, or has it also emerged on another world? Together, these rovers have laid the groundwork for future human exploration and potential colonization. By studying the terrain, testing technologies for producing oxygen from the thin Martian atmosphere, and identifying resources like water ice, they are paving the way for astronauts to one day set foot on the Red Planet. With each new discovery, these robotic pioneers bring us closer to understanding Mars' past, present, and its potential as a future home for humanity. As the next phase of the journey unfolds, the search for life on Mars takes center stage. While each rover has contributed to our understanding, the lingering hints of habitability lie in the chemical anomalies and patterns they have unearthed. For example, Curiosity's detection of complex organic molecules in ancient rocks was a groundbreaking moment. These molecules, made up of carbon and hydrogen, are fundamental to life as we know it. Even more fascinating were the seasonal variations in methane gas detected by the rover. On Earth, methane is often produced by biological activity, sparking the question of whether a similar process could be occurring on Mars. Perseverance has taken this investigation further by exploring the sedimentary layers in Jezero crater, an area once covered by water. These layers act like a time capsule, preserving a record of Mars' environmental history. By analyzing these samples, scientists hope to identify biosignatures, chemical or physical markers that could indicate past or present life. To add to the intrigue, some of the minerals found in Martian rocks, such as clays and carbonates, form in the presence of water and could provide ideal conditions for preserving microscopic life forms. There is also the possibility that microbial life, if it ever existed, could still survive beneath the surface in areas shielded from harsh radiation and temperature extremes. With every rock drilled, every sample analyzed, and every piece of data returned, the rovers keep inching us closer to answering one of the most profound questions of our time. Are we alone in the universe? The search for life on Mars not only reshapes our understanding of the red planet, but also forces us to confront the broader implications of finding, or not finding, life beyond Earth. Moving forward, this relentless pursuit of answers continues to inspire and drive future missions, ensuring that the dream of uncovering Mars' secrets lives on. Now turning to the Galileo Probe, this remarkable mission provided humanity with an unprecedented glimpse into the Jovian system, forever altering our understanding of the gas giant and its enigmatic moons. Launched in the late 20th century, Galileo not only captured stunning images of Jupiter's turbulent atmosphere, with its iconic Great Red Spot and powerful lightning storms, but it also unveiled groundbreaking insights about its moons, particularly Europa. Europa, slightly smaller than Earth's moon, emerged as one of the most promising candidates in the search for extraterrestrial life. Galileo's data revealed a smooth, icy surface crisscrossed with cracks, resembling the fractured crust of an ice-covered ocean. Beneath this frozen exterior, evidence pointed to the existence of a vast subsurface ocean, kept liquid by the tidal heating generated as Europa orbits Jupiter. This discovery was not merely an astronomical curiosity, it was a game-changer. On Earth, life thrives in deep oceanic environments around hydrothermal vents, where sunlight never penetrates and energy comes from chemical reactions instead. Could a similar process occur on Europa? Galileo's detection of certain salts and minerals on Europa's surface hinted that material from the ocean below might be making its way to the surface, further supporting the hypothesis of a hidden aquatic world teeming with potential. The implications are revolutionary. If life exists beyond Earth, even in such extreme conditions, it would suggest that life could be more common in the universe than we ever imagined. Galileo also raised questions about the moon's geologic activity, as evidence of plumes, jets of water vapor erupting from cracks in the ice was later confirmed by other missions. These plumes, offering a direct connection to the subsurface ocean, could hold clues to its chemical composition and potentially any signs of microbial life. By uncovering these mysteries, Galileo set the stage for future missions, such as the upcoming Europa Clipper, which aims to delve deeper into this icy moon's secrets. As Galileo's findings continue to inspire exploration, the question remains: if life can exist in Europa's dark, liquid depths, what other hidden corners of our solar system might harbor life as well? Now turning to the James Webb Space Telescope, this cutting-edge observatory represents the pinnacle of human ingenuity and one of the most ambitious tools ever built for unlocking the mysteries of the cosmos. Designed to be the successor to the Hubble Space Telescope, this marvel of engineering is equipped with a massive gold-coated mirror and advanced infrared sensors. These features enable it to peer deeper into the universe than ever before, capturing light from galaxies formed over 13 billion years ago, light that has traveled through space for nearly the entire history of the universe. By studying these ancient structures, the James Webb Telescope promises to shed light on how the first stars and galaxies came into existence, forging the foundations of everything we observe today. But its capabilities are not limited to unraveling our cosmic past. One of its most exciting applications is in the search for potentially habitable exoplanets orbiting distant stars. The telescope's highly sensitive instruments allow it to analyze the atmospheres of these worlds by detecting the faintest changes in starlight as planets pass in front of their host stars. Through this process, known as spectroscopy, scientists can identify the presence of key molecules such as water vapor, carbon dioxide, and methane ingredients that could indicate conditions suitable for life. Imagine discovering another Earth-like planet, complete with an atmosphere capable of sustaining life. Such a breakthrough would not only revolutionize our understanding of the universe, but also challenge us to reimagine our place within it. Furthermore, the James Webb Telescope is expected to uncover phenomena we cannot yet even conceive of, thanks to its unprecedented ability to detect objects too faint, distant, or obscured for previous telescopes. From probing enigmatic dark matter and energy to studying the birth and death of stars with unparalleled clarity, James Webb is poised to provide answers to some of humanity's most profound questions. This groundbreaking mission, only just beginning to deliver its treasure trove of data, holds the potential to redefine how we view the cosmos and ourselves. As the next phase of discoveries unfolds, we find ourselves on the brink of an era where the secrets of space are within closer reach than ever before. Moving forward, the James Webb Space Telescope's pursuit of exoplanets takes us into a realm of unparalleled possibilities. By focusing on exoplanets, planets outside our solar system, it pushes the boundaries of what we know about other star systems. With its advanced technology, this telescope can unravel secrets hidden in the atmospheres of these distant worlds. Its ability to perform spectroscopy, which detects the specific wavelengths of light absorbed and emitted by molecules, allows scientists to identify atmospheric compounds like oxygen, carbon dioxide, and methane. These components are not just fascinating data points, but could serve as potential biosignatures, clues that hint at the presence of life. Picture a scenario where James Webb identifies an atmosphere filled with the subtle but unmistakable markers of biological activity. Perhaps a planet where water vapor swirls in its skies, or methane exists in perfectly balanced quantities, potentially implying a living system maintaining its chemical equilibrium. Such a discovery would force us to grapple with the idea that life may not be unique to Earth. Beyond this, the telescope's capabilities extend to understanding the diversity of planetary systems. It can observe the formation of exoplanets in real time within stellar nurseries, providing rare glimpses into how these worlds emerge and evolve over millions of years. This opens doors to answering age-old questions, like whether Earth-like planets are common or extraordinary. By observing young planets still forming around their stars and mature systems that resemble our own, James Webb is painting a more comprehensive picture of the cosmos, one that prominently features the possibility of life elsewhere. Imagine living in an era where we regularly catalog planets that bear similarities to our own, where researchers can analyze their atmospheric conditions with precision, and where the search for life transitions from philosophical speculation to scientific exploration. The James Webb Telescope is not merely searching for other worlds, it is looking for other possibilities, other answers to the question that has haunted humanity for generations: are we alone? The implications of finding even the smallest hint of alien life would ripple through every aspect of our society, reshaping science, philosophy, and even how we define ourselves. As this mission continues to gather data from the cosmos, the discoveries it may hold could redefine our understanding of life's potential across the vastness of space. With the next phase of the journey in sight, we dive into the groundbreaking Cassini-Huygens mission, a venture that transformed our understanding of Saturn and its mesmerizing moons. Cassini's journey around the gas giant revealed a realm teeming with wonders, but two of Saturn's moons, Enceladus and Titan, emerged as the most enigmatic. Let's start with Enceladus, a moon that, while small in size, holds immense potential for rewriting the story of life in the cosmos. Cassini's instruments detected geysers of water ice erupting from cracks near its south pole, shooting material hundreds of miles into space. These geysers are not just visually stunning but scientifically revolutionary. They contain complex organic molecules, and their source has been traced to a subsurface ocean beneath the icy crust. This raises profound questions. Could this hidden ocean harbor microbial life, thriving in an environment warmed by geothermal energy? Enceladus has quickly become one of the most promising places to search for life beyond Earth, demonstrating that even the coldest, farthest reaches of our solar system can surprise us with their potential for habitability. Shifting our focus to another remarkable moon, Titan, we find a world that seems both alien and familiar. Titan is the only moon in our solar system with a thick atmosphere, one dominated by nitrogen and enriched with methane. Cassini delivered astonishing images of Titan's surface, revealing lakes and rivers not of water, but of liquid methane and ethane. These hydrocarbon seas mimic Earth's water cycle, complete with rain, rivers, and evaporation, creating a parallel world with striking similarities to our own despite the extreme cold. Additionally, the rich organic chemistry at work here presents tantalizing possibilities for exotic forms of life, potentially thriving in liquid methane instead of water. Together, Enceladus and Titan challenge our assumptions about where life could exist and in what forms. They remind us that life might not need to look like anything we've ever encountered and could be thriving in conditions we once deemed impossible. As the findings from Cassini and Huygens continue to ripple through the scientific community, their legacy inspires new missions to return to these moons and delve deeper into their mysteries. These incredible discoveries beg the question, if places like Enceladus and Titan hold such potential, what other secrets might the outer solar system be hiding? As the next challenge unfolds, we journey further into the cosmos with the New Horizons mission, a daring voyage that redefined our understanding of the distant worlds at the edge of our solar system. Launched with the goal of exploring Pluto and the Kuiper Belt beyond, New Horizons provided humanity with its first close-up look at these icy frontier regions. When it arrived at Pluto in 2015, the images it sent back left scientists and the public alike in awe. Pluto, once considered a cold, desolate dwarf planet, turned out to be a surprisingly dynamic world. Its surface reveals towering mountains made of water ice, vast plains covered in frozen nitrogen, and even evidence of possible cryovolcanism volcanoes spewing not molten rock but icy materials like water, ammonia, or methane. These findings suggest that beneath Pluto's frozen crust, there could be a warm interior, possibly even a subsurface ocean, challenging our perceptions of what makes a planet geologically active. Equally fascinating were the atmospheric studies, which showed Pluto's thin, hazy atmosphere undergoing changes as it orbits further from the Sun. This atmosphere, primarily composed of nitrogen, is continuously escaping into space, creating an extended tail stretching for thousands of miles. The discovery of such complexity on a small, distant world like Pluto underscores the sheer diversity and unpredictability of planetary science. But New Horizons' mission didn't end with Pluto. It ventured deeper into the Kuiper Belt, a region populated by ancient, icy bodies that hold clues to the early formation of our solar system. In 2019, the spacecraft encountered Arakoth, a small, elongated object that is one of the most primitive relics from the solar system's birth. Images of its strangely smooth, reddish surface revealed a story billions of years in the making, offering insights into how these early building blocks of planets came together. The revelations from New Horizons continue to reshape our understanding of the outer solar system. They show us that even in the most remote and frigid corners of our neighborhood, there are mysteries waiting to be uncovered, evidence of activity and processes that defy our expectations. As New Horizons sends back data from the Kuiper Belt, it reminds us of the vast, unexplored expanse that lies beyond, fueling hopes for future missions to delve even deeper into the secrets of our solar system's distant edges. Now turning to the International Space Station, humanity's remarkable outpost in orbit around Earth, we find an unparalleled platform for scientific discovery and innovation. Since its assembly began in the late 1990s, the International Space Station has functioned as a living, breathing laboratory, circling our planet every 90 minutes at a breathtaking speed of over 17,000 miles per hour. But beyond its awe-inspiring presence, the station plays a vital role in preparing humanity for the challenges of long-term space exploration. One of its most significant contributions is its ability to study the effects of microgravity on living organisms, providing scientists with invaluable insights into how the human body adapts to the unique conditions of space. For example, researchers have discovered that prolonged exposure to weightlessness can lead to muscle atrophy, bone density loss, and even changes in vision. By understanding these effects in detail, scientists are developing countermeasures such as specialized exercise regimens and nutritional guidelines to support astronauts on future missions to the Moon, Mars, and beyond. The International Space Station is also a testbed for advanced technologies that will be essential for deep space exploration. From water purification systems that recycle almost every drop on board to experiments with growing food in microgravity, the station offers a critical proving ground for sustainable living in space. These innovations are not only paving the way for long-term habitation on other worlds, but are also providing solutions to challenges here on Earth, such as access to clean water and efficient food production. Beyond its contributions to biology and technology, the International Space Station fosters unprecedented international collaboration. With countries like the United States, Russia, Japan, Canada, and multiple members of the European Space Agency working together, it stands as a testament to what humanity can achieve when it unites for a common purpose. This spirit of cooperation has allowed researchers from all over the world to conduct thousands of experiments that span from studying cosmic rays to mapping Earth's changing climate. But the legacy of the International Space Station does not stop there. Its ongoing work is refining our understanding of how to survive and thrive in hostile environments, offering a crucial stepping stone for the ambitious deep space missions that lie ahead. As we look to explore new frontiers, the lessons learned from the International Space Station will undoubtedly be the foundation upon which future generations build their journey into the stars. With the next phase of the journey in sight, let us consider how these insights might shape the future of space habitats, potentially transforming humanity's presence in the cosmos forever. With the next phase of the journey in sight, the lessons from the International Space Station are more than just milestones. They are building blocks for humanity's future in space. Imagine a permanent colony on the Moon, where the technology developed aboard the station, like advanced life support systems and energy-efficient recycling methods, forms the backbone of survival in a remote and hostile environment. These innovations are not just theoretical, they are practical solutions tested in orbit, ready to be adapted for lunar bases or even habitats on Mars. For instance, the ability to grow food in microgravity could evolve into sustainable agricultural systems, ensuring long-term food security for settlers on other celestial bodies. Furthermore, the insights gained from studying the effects of microgravity on human physiology will be critical in designing living spaces that minimize health risks during prolonged stays on the Moon or Mars. Radiation shielding, ergonomic habitat designs, and medical advancements driven by decades of research on the station will become essential components of these extraterrestrial homes. But the implications go even deeper. the International Space Station has proven that humans can work and thrive together in space for extended periods, despite differences in culture, language, and political systems. This collaborative spirit could be the key to establishing international partnerships for constructing and maintaining these future habitats. By pooling resources and expertise, nations could ensure that humanity's expansion into the cosmos is a collective endeavor rather than a competitive race. Picture a lunar village where scientists, engineers, and explorers from all corners of the globe work side by side, advancing not only their own understanding but also the collective knowledge of humanity. Moreover, these space habitats will not merely reflect survival, they will symbolize adaptability and innovation. The harsh conditions of the Moon and Mars will demand creative engineering, from designing structures that can withstand extreme temperature fluctuations to utilizing in situ resources like lunar regolith or Martian soil to build infrastructure. These challenges, daunting as they may seem, could revolutionize construction and resource utilization techniques that may one day be applied on Earth. The journey to create sustainable homes beyond our planet is not just an ambitious dream, it is a necessity for ensuring humanity's long-term survival and growth. As we stand on the cusp of this extraordinary chapter, it becomes clear that the enduring legacy of the International Space Station is not just about what we have learned, but about how those lessons will inspire and enable us to settle the next frontier. And speaking of next frontiers, let us now explore the groundbreaking discoveries made through the Rosetta and Philae mission, which took humanity to the surface of a comet for the very first time. Now turning to one of the most daring missions in space exploration, the Rosetta and Philae mission marked humanity's first ever landing on a comet, launched with the goal of unlocking secrets from the formation of the solar system. This ambitious project targeted Comet 67P, a celestial body more than 300 million miles away from Earth. The Rosetta spacecraft traveled for over 10 years, performing intricate maneuvers and gravity assists to finally reach its target. Once there, it released the Philae lander, which made an unprecedented touchdown on the comet's surface. Though the landing was far from smooth, Philae bounced across the surface before settling into a shadowed crevice. It still managed to send back some extraordinary data during its brief operational period. One of the most groundbreaking revelations was the detection of organic molecules, the very compounds believed to be essential for the development of life. This finding fueled theories that comets may have played a crucial role in delivering the building blocks of life to Earth billions of years ago, possibly even seeding our planet with the ingredients necessary for biology as we know it. In addition to this, Rosetta's instruments identified the comet's water composition, which turned out to be different from the water found in Earth's oceans. This surprising discovery challenged the long-standing hypothesis that Earth's water may have been delivered primarily by comets. The insights gained from this mission not only reshaped our understanding of comets, but also raised new questions about the origins of water and life on our planet. Beyond these scientific revelations, the mission showcased the incredible advancements in space technology and engineering. The precise coordination required to navigate Rosetta to its destination and successfully deploy Philae demonstrated the extent of human ingenuity and perseverance in the face of unprecedented challenges. Even after Philae's communication faded, Rosetta continued to study the comet up close, providing detailed images and data about its structure, surface activity, and composition. These observations have proven invaluable for scientists seeking to understand the role of comets in the broader context of our solar system's history. Ultimately, Rosetta and Philae's legacy is a testament to the relentless pursuit of knowledge and the boldness required to explore the unknown. By venturing to the surface of a comet, this mission not only expanded the horizons of science but also inspired a new generation to dream big. And as we reflect on what this mission revealed about the ancient past, it also stirs our imagination about the future mysteries waiting to be uncovered. With that, let us turn our attention to the Sun, the very heart of our solar system, and the daring mission of the Parker Solar Probe, which has ventured closer to this fiery furnace than any spacecraft in history. Now turning to the Parker Solar Probe, this mission represents a groundbreaking leap in our exploration of the Sun. Launched with the audacious goal of venturing closer to the Sun than any spacecraft in history, it was specifically designed to study the star that sustains life on Earth. Traveling through the Sun's outer atmosphere, known as the corona, the Parker Solar Probe has endured incredibly harsh conditions, withstanding temperatures of over 1 million degrees to collect data that was previously beyond our reach. Its mission is to unravel some of the most enduring mysteries about the Sun, including the origins of the solar wind, a stream of charged particles that flows outward through the solar system. These particles interact with Earth's magnetic field, creating phenomena such as the auroras, but also influencing space weather in ways that can disrupt satellites, power grids, and communication systems. The probe also aims to solve one of the most puzzling questions in astrophysics: why the corona is significantly hotter than the Sun's surface itself. While the Sun's surface measures around 10,000 degrees, the corona reaches temperatures of several million degrees, and understanding this phenomenon could provide key insights into the complex dynamics of stars. Equipped with cutting-edge instruments, the Parker Solar Probe has already made historic breakthroughs. By directly sampling the solar wind and the magnetic fields in the corona, it has provided data that is reshaping our understanding of how energy and heat move through the Sun's atmosphere. This mission is not only about understanding our Sun, it also has implications for the future of space exploration. By learning more about space weather, we can better protect astronauts and spacecraft as humanity ventures farther into the cosmos. The Parker Solar Probe's findings are helping scientists predict solar storms more accurately, which is crucial for safeguarding both technology and human lives. This daring mission is a testament to how far we are willing to go to comprehend our place in the universe. And with each orbit, as the spacecraft spirals closer to the Sun, it continues to push the limits of what humanity can achieve in the pursuit of knowledge. As we marvel at the Parker Solar Probe's journey, it is a reminder of how even the most forbidding corners of our solar system are within reach with determination and ingenuity. Now, let us move beyond our star and turn our focus to the Kepler Space Telescope, a mission that fundamentally transformed our understanding of planets beyond our solar system. Now turning to the Kepler Space Telescope, this mission has truly revolutionized our understanding of planets beyond our solar system. Launched with the primary goal of identifying worlds orbiting other stars, Kepler has opened our eyes to the staggering diversity of planetary systems in the universe. Before this mission, we knew of only a handful of exoplanets. By the time Kepler's primary mission concluded, it had confirmed the existence of thousands, with many more candidates still awaiting analysis. This flood of discoveries has shown us that planets are not just common, but are likely to outnumber the stars themselves. Kepler's most profound contributions include the identification of Earth-like planets residing in what scientists call the habitable zone, the region around a star where conditions could allow liquid water to exist on a planet's surface. These findings have profound implications for one of humanity's oldest and most captivating questions. Are we alone in the universe? Kepler's ability to detect these worlds relied on a simple but effective technique, observing tiny dips in a star's brightness caused by a planet passing in front of it, an event known as a transit. This method not only revealed a planet's existence, but also provided crucial details about its size and orbit. Among its most tantalizing discoveries are planets with similar sizes and temperatures to Earth, hinting that conditions suitable for life might not be as rare as once thought. These include planets like Kepler 452b, often called a super-Earth, which orbits in the habitable zone of a star remarkably similar to our Sun. Such discoveries challenge us to rethink the uniqueness of our planet and the potential for finding life in the cosmos. Moreover, Kepler's observations have shattered our preconceived notions about planetary systems. It showed us worlds vastly different from anything in our solar system, such as gas giants orbiting perilously close to their stars or planets locked in tidal resonance with multiple stars. These findings not only expand our understanding of what planets can be, but also raise new questions about how they form and evolve over time. The data collected by Kepler has become a treasure trove for scientists, fueling research that will continue to yield discoveries for decades. Beyond the scientific revelations, Kepler has ignited our imagination, providing a sense of cosmic connection. It reminds us that the conditions for life may not be confined to a single planet or even a single star system. As we continue to analyze its discoveries and dream of future missions aimed at directly observing these distant worlds, Kepler stands as a symbol of humanity's unrelenting curiosity. Moving forward, let us explore a newer instrument, the James Webb Space Telescope, which promises to take our quest for knowledge even further by unlocking deeper mysteries of the universe. With the next phase of the journey in sight, we turn our attention to the Artemis program, NASA's ambitious initiative to return humans to the Moon. This program isn't just about retracing the steps of past lunar missions. It's about paving a bold, new path for the future of space exploration. Named after Artemis, the twin sister of Apollo in Greek mythology, this effort signifies a renewed commitment to explore not only the Moon's surface, but also its untapped potential as a springboard for deeper space exploration. Artemis aims to establish a sustainable human presence on the Moon, laying the groundwork for future missions to Mars and beyond. But why return to the Moon now, decades after the last Apollo mission? The answer lies in the resources and opportunities the Moon holds. Unlike previous missions that involved brief visits, Artemis is focused on creating a long-term foothold. One key objective is to explore the Moon's South Pole, a region believed to hold vast deposits of water ice. This water could be converted into oxygen for astronauts to breathe, or even into rocket fuel for missions that venture further into the solar system. Essentially, the Moon could become a refueling station for humanity's interplanetary ambitions. Moreover, studying the Moon's geology could reveal clues about the early history of Earth and the solar system, providing insights we simply can't obtain from our planet alone. This program also aims to push the limits of technology and international collaboration. Artemis will utilize the most advanced spacecraft and launch systems ever designed, including the Space Launch System rocket and the Orion spacecraft. With a combination of robotic missions and human landings, Artemis is preparing us for the challenges of living and working on another celestial body. And the efforts are not solely NASA collaboration with international and private partners is a cornerstone of the program, signaling a new era of shared objectives in space exploration. Perhaps most exciting is the idea that Artemis is not the end goal but the beginning of something even greater. By mastering the challenges of lunar exploration, we move one step closer to a sustainable human presence on Mars. The skills and technologies developed under Artemis, like building habitats in harsh environments and generating life supporting materials from local resources, are critical stepping stones for venturing to the Red Planet. In essence, the Artemis program is shaping the future of humanity as a multi-planetary species, igniting dreams of exploration and survival far beyond Earth. As the possibilities unfold, it is clear that the Artemis program is more than just a return to the Moon. It is a defining moment in the narrative of space exploration, setting the stage for discoveries that could reshape our understanding of the universe and our place within it. Now, let's dive deeper into humanity's first steps toward becoming an interplanetary species by exploring SpaceX's monumental plans to colonize Mars. Now turning to one of the most ambitious undertakings in modern space exploration, we delve into SpaceX's groundbreaking plans to colonize Mars. Guided by the vision of making humanity a multi-planetary species, SpaceX has set its sights on the red planet as the next frontier for human settlement. At the core of this bold plan is the development of the Starship spacecraft, a fully reusable vehicle designed to carry humans and cargo to Mars and back. Starship represents a monumental leap in space travel technology, capable of transporting over 100 people in a single journey. Its revolutionary design is intended to dramatically reduce the cost of space travel, making the concept of colonizing another planet more than just science fiction. But the journey to Mars is far from straightforward. SpaceX faces challenges ranging from developing reliable life support systems and radiation shielding to the logistics of building a sustainable colony on a planet with an unforgiving environment. Mars has no breathable atmosphere, extreme temperature swings, and intense dust storms that could complicate long-term habitation. Yet SpaceX's engineers are tackling these challenges head-on, exploring solutions like creating habitats using Mars' natural resources and developing systems to produce water, oxygen, and fuel from the planet's soil and atmosphere. The mysteries of Mars itself add another layer of intrigue to this mission. Could the red planet, with its ancient riverbeds and signs of past water activity, have once harbored microbial life, and if so, could it still? These questions have captured the imagination of scientists and dreamers alike, making Mars exploration not just a technological challenge, but also a quest for answers about the origins of life in the universe. Establishing a presence on Mars could open up opportunities to explore these questions in ways never before possible. The idea of colonizing Mars also raises profound questions about humanity's future. What kind of society would we build on another planet? How would we adapt culturally, socially, and ethically to living so far from Earth? And perhaps most importantly, what lessons can be learned from such an endeavor that might help us address challenges here on our home planet? SpaceX's Mars mission is not just an engineering project, it is a daring experiment that could redefine what it means to be human. By confronting these challenges, SpaceX is pushing the boundaries of what is possible, sparking a new era of exploration and innovation. And as we stand on the cusp of interplanetary travel, the world watches with a mix of hope and wonder, knowing that the outcome of this mission could forever alter the course of human history. With SpaceX's aspirations painting a picture of a Martian future, the story of space exploration grows even more compelling. As we now shift our focus back to our celestial neighbor, India's Chandrayaan missions have illuminated the moon's mysteries in ways that could transform our understanding of lunar exploration. Now turning to India's remarkable contributions to the story of space exploration, the Chandrayaan missions stand out as a testament to both ingenuity and determination. These missions, spearheaded by the Indian Space Research Organization, have not only advanced our understanding of the moon, but have also positioned India as a key player in the global space community. Chandrayaan-1, India's first lunar probe, made history in more ways than one. Among its groundbreaking achievements was the discovery of water molecules on the moon's surface, a revelation that sent waves through the scientific community and fundamentally altered our perception of Earth's closest celestial neighbor. This discovery suggested that the moon may hold resources critical for future human settlement, such as water that could potentially be processed into oxygen or even fuel. Building on this success, Chandrayaan-2 sought to deepen our exploration of the moon by studying its south polar region, an area of key interest due to its shadowed craters where water ice is believed to exist. While the lander's soft landing attempt faced challenges, the orbiter component continues to deliver valuable data, including high-resolution imagery and information about the moon's mineral composition. These insights are critical stepping stones for any future missions aimed at permanent lunar bases or resource utilization. The significance of Chandrayaan extends beyond its scientific findings. It underscores a growing global focus on the moon as not just a subject of study, but as a potential outpost for humanity. The implications of these discoveries are vast. Water on the Moon could enable sustainable human presence, reducing our dependence on costly deliveries from Earth. Moreover, this opens up possibilities for using the Moon as a staging ground for deeper space missions, such as voyages to Mars or beyond. Imagine a future where rockets departing from lunar colonies cut down travel time and cost, revolutionizing how we explore the cosmos. Chandrayaan has paved the way for this vision, showing that even nations with modest space budgets can achieve discoveries that resonate across the world stage. India's efforts are also a reminder that the future of space exploration is becoming increasingly collaborative. As more nations, agencies, and private companies turn their focus to the Moon, partnerships may hold the key to unlocking its full potential. India's Chandrayaan program has shown that innovation and ambition can rewrite what's possible, inspiring countries and generations alike to look up and dream bigger. With water on the Moon no longer a question but a fact, humanity stands on the brink of an era where the Moon might serve as both a scientific laboratory and a stepping stone to the stars. As we delve deeper into the mysteries of the cosmos, India's Chandrayaan missions remind us how exploring even the closest corners of space can lead to discoveries that reshape our understanding of what lies beyond. Moving forward, the focus shifts to the extraordinary contributions of asteroid sample return missions, which promise to reveal secrets about the very foundation of our solar system. As the next phase of the journey unfolds, we turn our attention to two groundbreaking missions that have unlocked secrets hidden within asteroids, Japan's Hayabusa missions and NASA OSIRIS-REx mission. These ventures are nothing short of extraordinary, as they achieved the monumental feat of collecting and returning samples from asteroids, offering us a direct glimpse into the early days of our solar system. Hayabusa, meaning peregrine falcon in Japanese, was the first mission to successfully bring back asteroid samples to Earth. Targeting the asteroid Itokawa, Hayabusa overcame numerous technical challenges, including a malfunctioning engine and a complex landing process, to deliver minuscule but invaluable fragments of this celestial body. These samples revealed surprising details about asteroid composition, including traces of water and organic materials, sparking deeper questions about whether asteroids could have played a role in seeding life on Earth. Following in these trailblazing footsteps, the Hayabusa 2 mission expanded the scope of exploration by visiting the asteroid Ryugu. This time, the mission not only collected surface samples, but also performed a daring maneuver to create an artificial crater, allowing scientists to gather material from beneath the asteroid's surface. The significance of this achievement cannot be overstated. Subsurface samples are less altered by space weathering, providing a clearer picture of the asteroid's pristine composition. These findings may hold answers to some of the most profound questions about the origins of water and organic compounds in the solar system. Meanwhile, across the globe, NASA OSIRIS-REx mission targeted the asteroid Bennu, a celestial body believed to contain unaltered matter from the solar system's formation. The spacecraft not only mapped Bennu in stunning detail, but also executed a complex touch-and-go maneuver to collect samples. Bennu has intrigued scientists with its carbon-rich surface, raising the possibility that its materials could resemble the building blocks of life. The returned samples will undergo extensive study, potentially revealing insights into the chemistry that gave rise to planets, moons, and perhaps even life itself. The ability to study asteroid samples in laboratories here on Earth marks a transformative leap in our quest to understand the universe. Unlike data collected remotely, these samples allow for a level of analysis that simply cannot be achieved from afar. They preserve snapshots of the solar system's infancy, frozen in time, offering clues about how celestial bodies formed and evolved. Beyond their scientific impact, these missions may also redefine how we perceive asteroids, not merely as distant rocks, but as resources that could one day fuel space exploration. Imagine harnessing water from asteroids for fuel or using their minerals for construction in space, opening the door to sustainable off-Earth industries. The Hayabusa and OSIRIS-REx missions have proven that asteroids are more than cosmic relics. They are keys to understanding where we come from and where we might go. These feats of engineering and exploration demonstrate humanity's growing capability to reach farther into the cosmos and bring its mysteries back home. With every fragment of asteroid dust studied, we edge closer to unraveling the origins of our solar system and the conditions that made life possible. Moving forward, the story shifts to the incredible potential of mining those very asteroids, an endeavor that could forever change the landscape of space exploration and Earth's resource economy. As the next phase of the journey in sight, we dive into the intriguing concept of asteroid mining, a vision that could revolutionize not just space exploration, but also the very foundations of Earth's resource economy. The asteroid samples returned by the Hayabusa and OSIRIS-REx missions are only the beginning of what might one day become a new frontier in resource utilization. Imagine mining these celestial bodies for essential materials like metals, minerals, and even water, turning asteroids into supply hubs that fuel humanity's ventures into the cosmos. The feasibility of this concept is no longer confined to science fiction. With advancements in robotics, artificial intelligence, and propulsion technology, the tools needed to access these resources are rapidly becoming a reality. Asteroids are rich in elements such as platinum, gold, and rare earth metals, materials that are critical to modern technology but limited on Earth. Some studies suggest that a single small asteroid could contain more platinum than has ever been mined in human history. Beyond metals, water trapped within asteroids could be converted into hydrogen and oxygen, the basic components of rocket fuel, potentially establishing a self-sustaining supply chain for deeper space missions. This would not only reduce the need to transport resources from Earth, but also make long-term colonization of other planets more viable. The economic impact of asteroid mining could also be transformative. By tapping into these extraterrestrial reserves, we might reduce the environmental strain caused by terrestrial mining and meet the growing demand for resources as Earth's population and technological needs expand. However, the implications go far beyond economics. Developing asteroid mining capabilities would require unprecedented international cooperation, new legal frameworks for space resource rights, and innovative approaches to technology and logistics. These challenges could catalyze a global effort to rethink how humanity uses and shares resources, both on Earth and beyond. While the prospect of asteroid mining is thrilling, it also raises profound ethical and logistical questions. How do we ensure that this new industry benefits all of humanity rather than a select few? What environmental risks might be associated with disturbing celestial bodies? And how do we balance the ambitious drive for exploration with the responsibility to preserve the cosmic environment? These are questions that will need answers as we tread further into this uncharted territory. The lessons learned from missions like Hayabusa and OSIRIS-REx serve as a crucial foundation for this bold endeavor. They have shown us that the resources needed to sustain life and exploration may already exist in abundance, waiting to be unlocked. With every step forward, the dream of harnessing the wealth of the cosmos moves closer to becoming an integral part of our reality. As we look further into the possibilities of asteroid mining, the stage is set for a new chapter of exploration, one in which humanity may no longer be bound by the limits of Earth but instead thrive among the stars. Moving forward, we delve into one of the most iconic milestones in the exploration of Mars, the Viking missions of the 1970s. These missions, comprising 2 landers and orbiters, were the first to successfully reach the Martian surface and conduct detailed scientific studies. What makes the Viking program especially intriguing is its groundbreaking approach to searching for life. Equipped with experiments designed to detect microbial activity in Martian soil, the Viking landers conducted tests that remain a subject of heated debate even to this day. One of these experiments, known as the labeled release experiment, revealed chemical reactions in the soil that some scientists interpreted as potential evidence of microbial life. However, others argued that these results could be explained by non-biological chemical processes unique to the Martian environment. What made the findings so perplexing was that while the labeled release experiment offered results consistent with biological activity, other instruments on board detected no organic molecules, the fundamental building blocks of life as we know it. This contradiction sparked decades of scientific discourse with no definitive resolution in sight. Could it be that the Viking landers stumbled upon signs of life, only for the evidence to be overlooked due to the limitations of their technology or our understanding at the time? Or were the results simply a misunderstanding of a planet vastly different from Earth? These are questions that continue to fuel curiosity and inspire new missions. The Viking missions were also instrumental in shaping our broader understanding of Mars, revealing a cold, barren landscape with evidence of ancient riverbeds and floodplains. These findings hinted at a time when Mars might have been warmer, wetter, and potentially habitable. If microbial life had ever existed there, could it still be hiding somewhere today, perhaps beneath the surface or in protected regions? The Viking mission set the stage for future exploration, urging scientists to dig deeper, both literally and figuratively, into Mars' enigmatic past. As we reflect on the legacy of the Viking missions, their importance reaches far beyond their initial findings. They demonstrated humanity's ability to conduct complex experiments on another planet and raised profound questions about life beyond Earth. The lessons learned from Viking have directly influenced every subsequent mission to Mars, from the search for ancient water to the hunt for biosignatures. With advanced technology and renewed interest, the goal of definitively answering the questions raised by Viking feels closer than ever. As humanity continues this quest, the Viking missions remind us of the value of curiosity, perseverance, and the courage to ask the big questions. Moving forward, we dive into the ambitious horizons of Breakthrough Starshot, a revolutionary initiative that could redefine humanity's reach into the cosmos. This bold project, spearheaded by scientists and visionaries, aims to send tiny, lightweight probes traveling at an astonishing fraction of the speed of light to our nearest star system, Alpha Centauri. Imagine this: a fleet of miniature spacecraft no larger than a postage stamp, powered by a beam of light and capable of traversing interstellar distances within decades. Breakthrough Starshot represents a leap in both technological ingenuity and our ambitions to explore beyond the solar system. The primary goal of this mission is to uncover the secrets of planets orbiting Alpha Centauri, a star system located over 25 trillion miles away. Among these planets, one of the most intriguing is Proxima Centauri b, a rocky world residing in its star's habitable zone, a region where conditions might permit the presence of liquid water. What lies on this distant planet? Could it harbor an atmosphere rich in crucial elements? And most tantalizingly, could it support life? These are the questions Breakthrough Starshot seeks to answer, and in doing so, it could illuminate what it truly means to live in a universe where other habitable worlds might exist. But the mission does not stop there. Breakthrough Starshot also aims to study the interstellar medium, the vast, mysterious expanse of space between stars filled with dust, gas, and cosmic radiation. By probing these regions, scientists hope to gain unprecedented insights into the composition and dynamics of the interstellar environment, helping to piece together the story of how galaxies, stars, and perhaps even life itself come into being. The data from these journeys could redefine our understanding of the cosmos on a level never before imagined. However, the challenges are enormous. Accelerating the probes to such high speeds requires breakthroughs in laser technology and material science. Navigating the vast distances of interstellar space and ensuring the probes stay on course adds another layer of complexity. And then there's the matter of communication, how to send data back across such an unfathomable distance. Despite these hurdles, Breakthrough Starshot embodies the spirit of exploration that has defined humanity for centuries, the drive to push boundaries and seek answers to the unknown. If successful, this mission would mark the first time humanity ventures beyond the solar system to explore another star system, a monumental achievement not just for science, but for our species as a whole. It would symbolize the dawn of a new era, one where the stars become destinations rather than distant points of light. As we turn our gaze to Alpha Centauri, Breakthrough Starshot challenges us to imagine a future where interstellar travel is not just a dream, but a reality within our grasp. And speaking of interstellar ambitions, the next step in humanity's quest to reach the stars brings us face to face with the immense challenges of making such journeys possible. With the next phase of the journey in sight, let's delve into the formidable challenges that interstellar exploration presents and how overcoming them could transform humanity's understanding of our place in the universe. First, there's the monumental task of propulsion. To traverse the unfathomable distances between stars, we need speeds that dwarf anything achieved before. Current propulsion systems, like chemical rockets, are simply too slow and inefficient for such endeavors. Innovative solutions such as light sail technology, plasma engines, or even theoretical concepts like warp drives must be explored and developed. Each of these technologies requires breakthroughs not yet achieved, pushing the boundaries of physics and engineering. Another critical hurdle lies in shielding against the immense hazards of interstellar space. At the speeds required for such missions, even tiny particles of dust could cause catastrophic damage to spacecraft. Advanced shielding materials, or perhaps deflection systems, are crucial to protect both the probes and their delicate instruments. Then there's the challenge of energy. Powering a spacecraft across such vast distances for decades or even centuries demands revolutionary advancements in energy storage and generation. Miniaturized nuclear power sources or solar technologies capable of harvesting the faint starlight in deep space may hold the key. Communication poses another daunting obstacle. When a spacecraft is trillions of miles away, even a simple message could take years to reach Earth. Developing ways to transmit data efficiently and reliably over these distances without losing critical information is a puzzle that experts are racing to solve. Adding to this is the matter of navigation. How do you keep a probe on course when it's traveling through the vast, uncharted terrain of interstellar space, facing gravitational forces, cosmic radiation, and other unpredictable factors? Autonomous systems equipped with artificial intelligence may become indispensable, allowing these spacecraft to make decisions and adjustments independently. As immense as these technological challenges are, their solutions could unlock doors to a future where humanity is no longer confined to our solar system. Overcoming these hurdles would signify that we are ready to venture into the deep unknown, transforming interstellar travel from an ambitious idea into a tangible reality. It would mark a profound shift in how we see ourselves, not just as inhabitants of Earth, but as explorers of the galaxy capable of reaching out to the stars. Speaking of humanity's expanding reach, let's now turn our attention to another ambitious player in this cosmic journey, China's rapidly growing and pioneering space missions. Now turning to China's ambitious foray into space exploration, their recent and ongoing missions reveal a determined push to establish a significant presence in the cosmos. The Chang program, named after the mythological Chinese moon goddess, represents a series of lunar missions that have already achieved incredible milestones. Chang 4 made history as the first spacecraft to successfully land on the far side of the moon, providing us with groundbreaking data about this mysterious and unexplored region. The mission also included a biological experiment involving plants and insects, a glimpse into how future human colonies might sustain life on the Moon. Meanwhile, Chang 5 set another benchmark by bringing back lunar samples, something no mission had accomplished since the 1970s. These samples are already deepening our understanding of the Moon's evolution and revealing clues about its resource potential. While the Chang program focuses on Earth's natural satellite, the Tianwen missions set their sights on Mars, with the name Tianwen translating to heavenly questions and symbolizing humanity's eternal curiosity about the cosmos. Tianwen-1, China's first Mars mission, achieved an impressive trifecta by entering orbit, landing a rover named Zhurong, and conducting surface explorations all within a single mission. The data collected by Zhurong is helping scientists analyze the Martian surface, its climate history, and the potential for past life. What makes these missions particularly noteworthy is the speed and efficiency with which China has advanced its space technology, demonstrating an ability to achieve complex goals on a timeline that few anticipated. But the significance of China's lunar and Martian ambitions extends beyond the scientific realm. They signal a decisive shift in global space competition, challenging the dominance of more established players like the United States and Russia. By pushing forward with plans that include establishing a lunar base and exploring Mars with an eye toward eventual human missions, China is positioning itself not just as a participant, but as a leader in unlocking the mysteries of space. Such progress raises questions about how international collaboration and competition might evolve in this new era of space exploration. Will the race to explore the Moon and Mars lead to groundbreaking partnerships that unite humanity, or will it intensify competition over scientific discoveries and potential extraterrestrial resources? As we consider these possibilities, it becomes clear that China's contributions will play an increasingly pivotal role in shaping our collective journey into the cosmos. Speaking of the importance of collaboration in space exploration, it's time to delve into the future of global partnerships and how the quest for knowledge might unify or divide our efforts to unravel the universe's deepest mysteries. As the next phase of the journey comes into focus, the evolving dynamics of international collaboration in space exploration take center stage. China's rapid advancements from the Chang lunar missions to the Tianwen exploration of Mars present both opportunities and challenges for global space efforts. On one hand, these milestones create new possibilities for partnerships that could accelerate humanity's quest for knowledge. Imagine a scenario where China's expertise in rover technology joins forces with the United States' experience in deep space exploration, or where nations pool their resources to establish a sustainable lunar base. Such collaboration could lead to breakthroughs that no single country could achieve alone, opening doors to answering profound questions about our universe. On the other hand, these advancements raise the stakes in space competition. If nations prioritize exclusive discoveries or resource claims over shared progress, the potential for fragmentation grows. This could lead to an environment where secrecy and rivalry hamper the exchange of ideas, delaying humanity's collective progress in unraveling the cosmos mysteries. Yet, there is reason for hope. Recent discussions about creating international agreements for peaceful exploration and resource sharing suggest that countries recognize the importance of working together, even as competition intensifies. China's participation in these dialogues might signal a shift towards a new era of collaboration, where shared goals like identifying habitable exoplanets, unlocking the mysteries of dark matter, or defending Earth from potential asteroid threats take precedence over national rivalries. Whether the path forward leans towards unity or division, one thing is clear: the future of space cooperation will play a defining role in shaping humanity's destiny among the stars. As we reflect on this moment of potential, the question arises: will we choose to explore the universe as a united species, or will the divides of Earth follow us into the cosmos? Reflecting on the transformative nature of these missions, let's now take a moment to recap the monumental achievements we have explored and their implications for the future of human exploration. As we look back on these 20 extraordinary space missions, it becomes clear that each one has played a pivotal role in expanding our understanding of the universe and reshaping humanity's future. From the first bold steps on the Moon with Apollo 11 to the deep space revelations of the Voyager probes, from the groundbreaking discoveries of the Mars rovers to the cutting-edge advancements of the James Webb Space Telescope, these missions have not only pushed the boundaries of science but have also ignited our collective imagination. They have brought us closer to answering age-old questions about the origins of the cosmos, the existence of life beyond Earth, and the potential for humankind to thrive on other worlds. Each mission represents a step forward in unraveling the mysteries of space, a testament to the power of human curiosity and innovation. But as we stand on the cusp of new discoveries, one tantalizing question remains. Could any of these missions ultimately reveal that we are not alone in the universe? With so many possibilities still waiting to be explored, the journey ahead promises to be as thrilling as the milestones we have already achieved. What do you think? Which of these missions captured your imagination the most, and what are your hopes for the future of space exploration? Let us know in the comments below, and if you enjoyed this journey through the cosmos, be sure to like this video, subscribe to our channel, and hit the notification bell so you never miss an update on the mysteries of the universe. Together, let's keep reaching for the stars.